We're doing we have been doing trigonometry with like on the XY coordinate plane, like this kind of trig, and that's 50 degrees, and what's tangent. This chapter, we're going back to triangles, which is kind of where you guys started trig with. So what was that magic word that helped us remember? We used it last chapter too, but what was the magic word for trig? SOHCAHTOA. All right. So today's is a review because it's like right triangle trigonometry, which you've done since like the last chapter of geometry. But then we're getting into other triangle trigonometry that you have not done before. It's not bad, but today's supposed to be a review. All right. What does SO stand for? Sine of an angle equals. All right. There we go. Kind of quick here. Cosine of an angle is supposed to equal adjacent over hypotenuse in the right triangle, and tangent is equal to opposite and adjacent. Okay, and in a triangle, let's say this is angle A. What is the opposite of this angle? Side what? BC. There is not an opposite. An angle can be opposite a side, or a side is opposite an angle. There's not an angle opposite another angle on a triangle. Okay, so this is opposite. What's this side called? Adjacent. AC is adjacent, yes. And then this side is the hypotenuse. Okay, so the hypotenuse and the adjacent side are both adjacent to angle A, but the hypotenuse is always the longest side of the triangle. It's always across from the 90-degree angle. Okay. You guys, you remember all this? I'm kind of assuming you probably do. So sometimes they'll just ask, and these are popular, like ACT questions. Has anybody taken the ACT? Remember questions like this, Eli, and thing? Sometimes they'll be like, what's sine of A? Okay, and because sine is opposite over hypotenuse, well, they'll have numbers up here in that case. They might put like a 3 and a 5. So sine of it, and this, we'll say this is a 4. Sine of A would equal 3 over 5. And sometimes we'll know the angle, like say this is 30 degrees or something, and we won't know one of the sides. So you could use, instead of saying sine of A, you could say sine of 30 equals opposite over adjacent, so x over 5. And how would we solve this for x? You guys recall? Yeah, multiply by 5. Sine of 30 is something we plug in the calculator. By the way, last chapter, your calculator might still be set on radians from last chapter, so you would need to change it. I don't think there's any radians in this chapter, but I could be wrong. But make sure your calculator's on degrees or you'll get this one wrong. So sine of 30 is something you put in the calculator. It spits out a decimal. But to solve for x, because this is x divided by 5, you would just multiply by 5. So you could plug in like sine of 30 times 5. Times 5. And that would give you x. And it should be, well, in this case it would be, I don't know, some weird decimal is normally what it is, and they'll tell you to round it off, like the 10th place or something. Okay, and then sometimes we know the sides, but they asked us to find the angle. So in this case, it's sine of A equals 3 over 5. How do we figure out what this angle is? You guys forget? If you do sine inverse of 3/5, that will give you angle A. Okay, so those are kind of like the three main things that we do. Find the missing side. By the way, if it was like this, sine of 30, instead of x over 5, let's say it was like 5 over x, how do we do it when the x is on the bottom? What happens is, if you multiply both sides by x, this just goes away. But then to solve for x, you'd have to divide by sine of 30. So when x is in the denominator, basically what happens is these two switch places. So x equals 5 divided by sine of 30. And you plug that in the calculator, it should give you the answer. Alright. Yeah. Now let's go ahead and get started. These are a little bit of pains because they didn't draw the picture for us, so we kind of have to draw our own picture. But we're not doing a ton of problems though, so it shouldn't be too bad. Throughout the exercises, give angle measures to the nearest tenth of a degree, so rounding to the tenth place on the degrees, and links to 3 significant digits. You guys remember what 3 significant digits meant? It means that you were just round to the third digit, whatever digits you have. So it could be like 52.1 or 6.47 or, just 3 digits in your answer. Okay. But on the degrees, it said round to the 10th place, first decimal. Okay, number 1, in triangle ABC, angle A is 90 degrees. So I'm going to draw a little picture, help me out here. A is the right angle, B is 25 degrees. Okay, it doesn't really matter where you put B and C. The picture is not that important. I mean, A is the 90 degree angle. B is 25. We're supposed to find B and C. Okay, so when they put little b, that means side B. Side B is opposite of angle B. So if this is angle C, this is like a capital C. Side C would be right here. This is angle A, this is side A. Okay, so we're missing a fact though. Hold on. I don't have enough information. A equals 18. So the hypotenuse is 18. So they're asking for side B and side C. By the way, how would I find angle C? Yeah, these 3 angles in a triangle should add up to 180, right? So if I do 180 minus these 2, that would give me that one. Or just 180 minus 90, we'll use 90 for these 2. 90 minus 25, that'll give me that angle. Okay, let's start with side B. So we need an angle on trig. And starting from this angle, the side that I'm looking for is the what side? Opposite. I can't use this side because it's another variable. You can't solve with 2 variables. So I need to use this side. This is the relative to this. This is the what side? Hypotenuse. So I need the trig function that deals with opposite and hypotenuse, which was sine. Yeah, it goes back to SOHCAHTOA. Sine gives me opposite over hypotenuse. Sine of the angle equals the opposite side over the hypotenuse side. So sine of 25 degrees equals opposite B over J, or hypotenuse 18. And what do we plug in the calculator? To solve for B, since B is being divided by 18, you would multiply by 18. So sine of 25 times 18. Let's everybody plug it in, make sure our calculators are working right. We got, the book says, well, what did you guys get? 7.61. So the directions were 3 digits, rounded to the third digit. So yeah, 7.61. So hopefully you got that on your calculator. Okay, and then we also need side C. So relative to this angle, side C is the, by the way, you cannot use a 90-degree angle to do this. Yeah, you can only use these acute angles. We could use angle C, which is like 65, but relative to this angle, C is the what side? Adjacent. Now, we do know the opposite now, but because this is a rounded value, it will be less accurate. So we'll just use the 18 still. So relative to this angle, we're looking for the adjacent. We have the hypotenuse. Which trig function deals with adjacent hypotenuse? Cosine. It's cosine of the angle, cosine of 25, is supposed to equal the ratio of the adjacent over hypotenuse. So it's cosine of 25 this time times 18. When the book said 16.3. 3 digits. Alright, is it all coming back to you now? Here's mine. Number 3. Okay, in triangle DEF, angle D is 90. Alright, so D is the right angle. E and F, doesn't really matter which is which, it's just a rough picture. It says the angle E is 12 degrees. And side E, little e, is 9. So if this is angle E, this is side E. And are we looking for side F and side D, I'm guessing? Yes, okay. Pretty similar. Okay, Eli, relative to the 12 degrees to angle E over here, this is the what side? Opposite. And I guess let's go for D. D is the what side? Which trig function does opposite and hypotenuse? So, sine, yeah, sine is opposite over hypotenuse, SOH, so SOHCAHTOA. So it'll be sine of the angle, sine of 12 degrees, equals the opposite over hypotenuse. Now what's different on this problem is our variable is in the denominator. So how do we fix it? Yeah, when you multiply by D, it kind of moves up here and goes away on the side. And then you divide by sine of 12 and it goes down. And these two switch spots, basically. So D equals 9 divided by sine of 12. And you can plug that in your calculator all at once. Let's see, so the book says 43.3. And then we need F. So Forrest, relative to this angle, F is the what side?
Adjacent.
So we'll use the opposite again. So which trig function does opposite and adjacent? Tangent. So it's tangent of 12 equals opposite TOA over adjacent. You guys like my little curly QF? It's fancy. Alright. So again, the variable's in the denominator, so we multiply by F, it goes up there. Divide by tangent of 12, it goes down there. So F equals 9 divided by tangent of 12. Did you guys know, back in the olden days, probably didn't, they used right triangle trigonometry to navigate ships. Like to go from Europe to America, that kind of thing. And they used stars too. They had to wait till it was nighttime to make sure they were on the right course. Fun fact. All right. Let's see. 42.3 is what it says. Nowadays, I imagine they do use it in rocket science for like directing paths and stuff. Rocket science would just be like, we need to get the satellite into orbit, and how fast, what angle should it be shooting at, how fast, so that it, doesn't fly off into space, doesn't crash down to Earth. Huh? Oh. You don't want me to do an extra problem?
So would you have done 4 and 5?
Nah. No, I'll figure it out eventually. Something's not right here. Okay, number 5, use the diagram on the right to find sine of A. Okay, so sine of A is supposed to tell, okay, before we do that, actually, we kind of need to figure out C. So this is not a trigonometry question. How do we find side C in that triangle? Pythagorean theorem, you guys remember that? A lot of times anytime you see a right triangle, this is another ACT fave, like Pythagorean theorem. Yeah, 12 squared plus 5 squared equals this squared. I guess it's C, isn't it? Yeah. This is the second most popular right triangle. Here, I'll actually do it. 12 squared plus 5 squared equals C squared. 25 plus 144 is 169. So C squared is 169. So how do we find C? Square root. And that comes out as 13. Because it's the most popular right triangle is a 3, 4, 5. Because it's the smallest numbers that come out nice. This is the second most popular because it's the smallest that comes out nice after that. 5, 12, 13, right triangle. Most right triangles are really weird decimals or square roots, but occasionally they come out really clean. So, sine of A, this is A, this is B, this is C. Alright, sine of A is supposed to equal opposite over hypotenuse. So, opposite hypotenuse. Cosine of B, cosine is supposed to tell us, yeah. And notice though, they changed it to angle B. So that's a little different. So B is up here, so what's the adjacent to B? 5, yeah. And the hypotenuse is always that one. So this one's also 5 over 13. I think they're trying to get us to notice a pattern here. When you do sine and cosine of the opposite, of the different angle, it comes out the same. Tangent of A. What's tangent supposed to tell us? Yep. So opposite is 5, adjacent is 12. Okay, I didn't go over these again. Cotangent, secant, cosecant. So maybe I'll scroll up here real quick. What went with sine, I guess. Let's start with sine. Cosecant. So cosecant would equal just, hypotenuse over opposite. Okay, what would, with cosine? secant. So secant would just be hypotenuse over adjacent. I call them the reciprocal functions. It just means they're like upside down as a fraction. And then what goes with tangent is cotangent. Adjacent over opposite. If you can remember what pairs with what, then you can just flip them upside down. That's the easiest way, I think, to do it. Cotangent is the one that seems like it should go together, tangent, cotangent. I just remember cosecant seems like it should go with cosine, but it doesn't. So these two are flipped. That's how I remembered it back in the day when I was your guys' age. All right. So D is cotangent of B. So cotangent is tangent flipped. So instead of opposite over adjacent, it's adjacent over opposite. And we're also using angle B on this one. So adjacent over opposite. So I think they're trying to show us like when you do tangent, cotangent of the different angles that come out the same. Secant of A. So secant goes with cosine. Cosine's adjacent over hypotenuse. So this, we're looking for hypotenuse over adjacent. So hypotenuse, adjacent. 13 twelfths. And then cosecant of B. Guess what that's going to be. So cosecant goes with cosine. Cosecant goes with sine. Sine is opposite over hypotenuse, so we're looking for hypotenuse over opposite. B. Hypotenuse, opposite. Okay, what was 7 or 6? I mean. All right. So on 6A, they're like using the same picture. What do you notice about sine of A and cosine of B? So they're like referencing the problem we just did. What do you notice about sine of A and cosine of B? They're equal. Yeah, they're the same. So that's all they wanted. They wanted you to notice they were equal. Okay, number 7, find the acute angles of a 3, 4, 5 right triangle. Remember I said 3, 4, 5 is like the most common right triangle. 5 would have to be the hypotenuse. The hypotenuse is always the largest. The hypotenuse is always opposite the right angle. Okay, so it said find the two acute angles. Just for convenience sake, I'll call them A and B. So how do I find an angle? Well, since we know all three sides, we could actually use sine or cosine or tangent because we got all the sides we need. So I guess I'll just do sine. So sine of this angle is supposed to equal what? Opposite, right? 3 over 5. Opposite over hypotenuse. See if you guys remember this time. So how do I figure out what this angle is? There you go. Sine inverse of 3/5. And up at the beginning of the assignment, they said round angles to 1/10 of a degree. I think they got 36.9 degrees. You guys concur? All right, then, okay, we still need angle B. There's actually 2 ways we can do this. Anybody think of the other way we can do this?
90 minus 30.
Since we know these two, we kind of just cheat. These three should add up to 180. So we could just do 180 minus 90 minus that to get that. You could do trig again, the same kind of trig. But it's basically it's 90 minus 36.9, which would be 53.1. What did I put up there? 10, 13 through 16. All right. Yeah, that's easy. I actually like those problems more than these.
What's that two day?
It's half day, due by the end of class.
Yeah.
Okay, the legs in an isosceles right triangle are 1 unit long. Do you guys remember what isosceles means?
Two are the same.
Two the same. And on a right triangle, if it's isosceles, it has to be the legs. Because the hypotenuse is always the biggest. So anyway, the legs are 1. Okay, A says find the length of the hypotenuse. So how could we find this? 1 squared plus 1 squared equals c squared, I guess. 1 squared is 1. 1 plus 1 is 2. So what's it going to be? Square root of 2. You guys remember this triangle? 1, 1 square root of 2? It's a special triangle. Yeah. It's a 45, 45, 90. If these two sides are equal, it's an isosceles triangle. These two, we call them base angles in geometry, have to be equal, which means these both have to be 45 degrees. And once upon a time, we learned that like 45, 45, 90, the ratio of the sides is 1 to 1 to square root of 2. But, okay, anyways. A is square root of 2. That was the A answer. B says find the exact value of tangent of 45. Back when they wrote this book, calculators couldn't give you the exact answer because it's a square root answer. But now your calculators can. But it's not that hard now that we have this picture. So on the first one, tangent of 45, well, here's a 45 degree angle and tangent is opposite over adjacent. 1 over 1, so it's 1. Now, even dumb calculators can give you a 1, right? Even very old basic calculators can spit out a 1. It's the second answer that the old calculators couldn't handle. Sine of 45. So here's a 45. Sine is opposite over hypotenuse. So it's 1 over square root of 2. Which, you can't leave the square root on the bottom, so you have to multiply by square root of 2 or 2. Square root of 2. Square root of 2 times square root of 2 is 2. 1 times square root of 2 is square root of 2. Anyways. But I think your calculators can do that. So that's why I have not spent as much time talking about special triangles. Because I think your calculators can handle them. Cosine of 45 is the exact same. So cosine is adjacent over hypotenuse. So it's 1 over square root of 2 again, which is square root of 2 over 2. C says convert the answers in B to decimal form. Compare these with the values obtained from the calculator. So yeah, C is kind of the outdated question. They wanted you to notice that the decimal you got on the calculator matches the decimal value of this. So we're just going to skip C. Actually, this B thing is kind of wrong. This was like B part 1. Number 9B part 1. Number 9B part 2. Number 9B part 3. You can skip C, we'll skip C. I don't even know how you would show that you did C. I guess you could write the decimal down, that kind of. So on 10C, you can skip that too, it's the same idea. On 10A, I'm guessing you guys forgot this one. It says it's 30, 60, 90. Right triangle. This is the other kind of special triangle. The hypotenuse is 2 units long. You guys remember this? Yeah. The short leg is half the hypotenuse, and the long leg is square root of 3 times bigger than that. So that's kind of the answer to 10A. On B, do I care if you use a calculator? No, I guess not. I suppose not. All right. Unless your calculator spits out a decimal, in that case, you need a better calculator, or you could use the picture to help you do it. Okay, 13. These are the same questions. I actually like these better. These are pretty quick questions. An airplane is at an elevation of 35,000 feet. Well, what does that mean? If you didn't know what that meant, it shows you in the picture. That means the airplane is 35,000 feet above ground. Okay, when it begins its approach to an airport, its angle of descent is 6 degrees. Okay, this is the kind of important part. So angle of descent means, so straight ahead is like 0 degrees. So if you're descending at a 6-degree angle, that means from straight ahead, it's hard for me to draw an angle that small, but this would be 6 degrees right here. Okay. Notice though that 6 degrees is not inside this triangle. Let's see if you guys remember a little geometry here. So this line and this line, what kind of lines are these right here? This line, parallel lines. So if you have parallel lines and a line that crosses those parallel lines, we know stuff about these angles.
The ones that are across from each other.
Like these two, they're called alternate interior angles. They're the same. And in this picture, 6 degrees and this angle right here are alternate interior angles between parallel lines. So 6 degrees also. Another trick we could have used, what's this angle right here? 90. So if this is 6, this would be 90 minus 6. So this is 84 degrees. So we could use this angle or we could use that angle. And anyway, the vertical airplane straight up and the ground, those are going to be perpendicular, right? So I got my 90 degree in my right triangle. The question is, what's the distance between the airport and the point on the ground directly below the plane? So, point on the ground directly below the plane, airplane's heading towards the airport over here somewhere. So we're looking for that. You could use this angle, you could use this angle. Relative to this angle, what side am I looking for? Adjacent. And the side I already know. Which trig function deals with opposite and adjacent? Tangent. So it's tangent of this angle equals opposite 35,000 over adjacent. We could also use the 84-degree angle. How do we solve for x?
What?
Yeah, these two switch spots. X equals 35,000 divided by tangent of 6.
That's literally the same thing you got.
Oh, there's a B question. Oh, I didn't write this one down. What'd you guys get?
333,002.
Okay. They just put this. That was in feet. Okay, do you guys know how we would turn that into miles, by the way?
Divide by 780.
Divide by 5,280. Because it takes 5,280 of those to make a mile. So how many of 5,280s are inside of that? B, what is the approximate distance between the plane and the airport? I think what they mean by that is the direct, like, air distance. So a lot of times they call this the ground distance. So this would be like the direct, air distance. So we're looking for the hypotenuse. So relative to 6 degrees, opposite hypotenuse. So sine equals opposite over hypotenuse. So y would equal 35,000 divided by sine of 6. Those two switch. Kind of the same thing as A, the A question. They got almost the same answer. 6 degrees is a really shallow, my picture doesn't show it very well. 6 degrees is a really shallow angle. The picture would look more like this, like the plane is barely dropping. So these two are very close to the same length. All right. 15. This is taking longer than I anticipated. But I still want to do 15 and 16.
Can we skip 14?
No. They drew a picture for you on 14. Well, on 14, instead of saying angle of descent, they say angle of depression, which is the same thing. So the guy in the lighthouse looks down at a 3-degree angle to see the ship. That means the guy in the ship would be looking up at 3 degrees. It's basically the same problem. There's only one question on 14 though. Okay, 15. A student looks out of a second-story school window and sees the top of a school flagpole at an elevation of 22 degrees. The student is 18 feet above the ground and 50 feet from this flagpole. Find the height. Okay, if they hadn't drawn a picture, this one would be challenging, I think. So the kid is starting 18 feet above ground in his little window there. And then he's looking out to the flagpole, which is, there it is, okay. How far away from the kid? 50 feet. You guys know this symbol meant feet? Little thing. And I probably should have drawn my flagpole taller, but it says, well, actually that's close to right. Yeah, to see the top of the flagpole, the kid has to look up at 22 degrees. Okay, so how are we going to find the height of the flag? Where would this 18 go? Where else could I put this 18 feet in the picture? Yeah, from like here to here is 18 feet. So to find the height of the flagpole, I need, wait, what's this X doing there? I need this, the height, this part of the flagpole, and just add that to the 18 feet from there. Okay. So, relative to the angle they gave us, I'm looking for the what side? Opposite. And I have the, which trig function deals opposite adjacent? Tangent. Tangent of 22 degrees equals opposite over adjacent. The easier version because x is on top, so we just need to do tangent of 22 times 50. $20.2. But is that the final answer? No, I wouldn't have said that if it was. How do I find the final answer? Add these two parts of the flag together to find the total flag height. So that plus that. 38.2. Oh, I think I realized why they rounded on B. They're using the same directions of 3 significant digits. Okay, so on 13A, that's why they rounded to 333,000 feet. Now, if you'd put 333,002 feet, I wouldn't count that wrong. But, yeah, that's why they only use 3 digits. That took longer than I anticipated. I think 2 days is too much, though. We'll call it a day and a half assignment, so maybe I'll give you some time to work on this tomorrow.